Hi everyone, my name is Rosika and welcome back to my channel. In the previous video, we have completed exercise 1.1 of chapter 1 real numbers of NCERT class 10 mathematics book. In this video, we will be completing exercise 1.2 and all the questions. The link for the previous video will be provided in the description box. Do like the video and subscribe to my channel. Let's start. We have question number 1 over here. Prove that root 5 is irrational. To do that, first we will assume root 5 to be a rational number. Okay, here rationals can be written in the form P by Q, where P and Q are integers and Q is not equals to 0 and P and Q are co-primes or co-prime numbers. Now what does co-prime number mean? Here co-prime number means that any two numbers, if they are co-prime numbers, they have only one as a common factor. For example, 2 by 3. 2 and 3 has only one as a common factor. Next example, let us take 6 by 4. Are these co-primes? No, because this is further again divisible. That is 2 into 2 is 4, 2 into 3 is 6. That means 6 and 4 have 1 and 2 as their common factor. Since 6 and 4 have common factor other than 1, that is 2, they are not co-prime numbers, but 2 and 3 are co-prime numbers. Now here we will assume root 5 equals P by Q, where writing these two conditions are enough. Next step would be, since we have assumed that root 5 is a rational number, we can write it in the form P by Q, and I have already explained what P by Q means over here. Now simple cross multiplication equals P. We will square both the sides. Now next we have 5q square equals p square. Let us take this as equation 1. This will be required later on. Next step would be, let us take 5 to the denominator of right hand side. Here in this equation we can see that p square is divisible by 5. Okay, p square is divisible by 5. Why is it so? Because we have assumed p and q to be integers, where p and q are integers over here, and q is not equals to 0. So q square is something or some number that is achieved when p square is divided by 5. That means p square is divisible by 5. Hence, p is divisible by 5. Over here, let's go back to what we have discussed regarding p and q. P and q are integers, okay. Q is not equals to 0, okay. P and q are co-prime numbers, that is p and q should only be divisible by 1. Here what we have concluded is p is divisible by 5. That means p is having 1 and 5 as its factor. Now since p is divisible by 5, 5 into something is p, right? P is divisible by 5. With if p square divisible by 5 gives us q square, let us assume let us assume p by 5. When p is divided by 5, we get a. When p square is divided by 5, we get q square from this equation over here, which is provided from the solution. This is our assumption that when p is divided by 5, we get a. Now we will move forward with this equation, this one. Let's say for some integer a, p by 5 equals a, or we can write p equals to 5a, squaring both the sides. Now here why we are squaring both the sides? To get p square, so that we could replace p square with the equation 1, the value of p square from equation 1. Here we get p square equals to 25, 5 into 5, 25 into a square. Now what is p square? It is 5q square from equation 1. 5q square equals 25a square. We can write it from equation 1. Okay. Next we have 5 into 1 is 5, 5 into 5 is 25. So q square equals to 5 into a square, or we can write q square by 5 equals to a square. See, right over here, what we have seen before is p square is divisible by 5. P square is divisible by 5. Hence, p is divisible by 5. Here we have got that q square is divisible by 5. So the same way, obviously q is also divisible by 5. So here we came to a conclusion that p and q both are divisible by 5. That is, p and q are not co-prime numbers. Thus, we can draw a conclusion that root 5 is irrational. Did you understand this one? Now let's move on to question number 2. Okay, so we have question number 2 over here. Prove that 3 plus 2 root 5 is rational. To prove it, again, let us assume. Now we already know the conditions of rational number from this part. Now we can write 3 plus, that is 2 root 5 equals p by q. Okay. Next, what we have to write over here? We have to solve the equation. That is 3 plus 2 root 5 equals p by q, or 2 root 5 equals p by q minus 3 root 5 equals p by q minus 3 into half, or we can write it in the form p minus 3q divided by, we know that this part is rational. Why? Because as p, q, 3 and 2 are integers, 2 and 3 are already integers, p and q we have assumed to be integers. Irrational. Since we have proved over here root 5 is a rational number, since we have got here that root 5 is a rational number, this contradicts the fact. It is contrary to the fact that root 5 is irrational, since we have already proved root 5 is irrational. Thus, we can draw a conclusion that 3 plus 2 root 5 is irrational. Here it is proved. The same way we can assume, let us assume 1 by root 2 equals p by, or we can write it root 2 equals to q by p. We can write over here, since p and q are integers, we can conclude that root 2 is rational number. Now over here, because of q and p, since they are integers, we assume that root 2 is a rational number. But we know that root 2 is not a rational number. It is an irrational number, which irrational. Thus, we can draw a conclusion that 1 by root 2 is irrational. Next we have proof that 7 root 5 is irrational. Same way, let us assume next what we have to do, we have to keep the square root side on the left hand side and all the integers towards right hand side. Here again p, q and 7 are integers, hence p by 7q is rational number, okay, which can conclude therefore root 5 is also rational. But we know that root 5 is not a rational number. So we can conclude, or thus we can draw a conclusion that 7 root 5 is irrational. Okay, here moving towards the last question. Here we have to prove 6 plus root 2 is rational number. 6 plus root 2 is irrational. Let us assume to 0. Next we can write p by q minus 6. Here p, q and 6 all are integers. Hence p by q minus 6 is rational. Now, so we can say that root 2 is rational because p by q minus 6 equals root 2. But we know that root 2 is not rational. It is irrational number, which hence 6 plus root 2 is irrational, which is also proved. So here we have completed exercise 1.2 and chapter 1, that is real numbers. From the next video onwards, we will move towards chapter 2 and the following exercises. Till then, stay tuned and subscribe to my channel. Bye bye.